penuh berisi guru ayu, mencapai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, dan good afternoon everyone. Welcome back to Pusat Tuisyen Akademi Youtuber, Panitia Fizik SPM. So this is really the first lesson after Panitia Fizik Form 4 in 2024. So I think this is still a right time to wish you all Happy New Year. Okay, so today you are going to learn subject Physics Form 4 in this 1 hours. And I am going to continue the subtopic in the chapter 6, 6.2, total internal reflection. So I introduce myself. I am Mr.Peh. Currently, I am teaching at KTE, College Tingkatan 6, Tun Fatimah, Melaka. I am the teacher on duty for this week. So please subscribe my channel to show your support to me, and like and share my lesson of today so that more of your friends are able to benefit from this lesson. So without further ado, I think let us start our lesson today. So as I mentioned just now, I'm going to continue the subtopic of chapter 6. So the chapter 6 will be the last chapter for Physics Form 4. And I'm going to continue the subtopic of 6.2, total internal reflection. So in this subtopic, we have total about 4 lessons. 4 learning standards are going to learn. So the first learning standard will be, you must be able to describe the critical angle and the total internal reflection. Okay, so firstly, let us define the critical angle. Okay, so the critical angle is the angle of incidence in the denser medium when the angle of reflection is less dense medium is 90. So what is the meaning of this? So you can look at this figure. Okay, so here the denser medium is actually the semicircular glass block. So which is denser than the A? Okay, so you can refer back the definition, mention that the angle of incident angle in denser medium. So that means here the angle of incident in denser medium here is referring to here. You can see this is an incident ray, and the angle of incident ray to normal line, so will be incident angle. And this incident angle in the denser medium will be known as critical angle when the refracted angle, which is showing at this line, reflected ray, and the angle at the less than median, which is at A, is equal to 90. So the incident angle we will know as critical angle. Okay, so I repeat. So the incident angle at denser median will know as critical angle when the refracted angle at the less dense median, which is A here, is equal to 90 degrees. Okay, so you can see from the another picture here. So the incident angle is here. So you can see the incident angle will be here. And when the refracted ray at 90 degrees at less than median, so our incident angle will know as critical angle. Okay, so students, I hope that you understand the definition for critical angle. And actually, you can get my worksheet for this lesson with the link I'm showing here. Okay, so you can download through the MO email. Okay, so to get my worksheet today. Okay, then the next, you need to understand and define the total internal reflection. Okay, so what is the total internal reflection? So the total internal reflection is defined as a phenomenon. So the total internal reflection is the phenomenon where will be occur when the light travel from denser medium to less than transparent medium here. So will be actually same as just now. Just the total internal reflection will be occur when the angle incident is greater than critical angle. Okay, so here to let the total internal reflection to occur, so you need to have two conditions. Okay, so first, the light travel must be from denser medium to less than medium. Okay, so for example, here, the semicircular glass block will be the denser medium, and then the A will be the less than medium. Then the second condition will be an angle of the incident must be greater than critical angle. As we just defined the definition of critical angle, so where the incident angle, see here. So when the incident angle, incident ray is here, so the reflected ray will be here. When the incident angle is greater than critical angle, where showing by this line, so you can see there will be no reflection will be occur. And then you can see the light will be reflected and known as a reflected ray. Okay, so again, you can look at this picture. So the light ray here is actually greater than critical angle. So the critical angle is at this line. Okay, so when your incident ray is greater than the critical angle, so you can see this is a refracted ray. And this phenomenon we know as total internal reflection. Okay. Hi, Cikgu Hasnitah.
Yeah, hi Mr. Peh. Sorry, saya lambat sikit.
Okay, no problem. Okay, so let us continue. Okay, so
Okay.
we just define the critical angle together with total internal reflection. Okay, so now we go to the experiment. One of the activity 6.3 at the page 242 at your textbook is the experiment. It is actually not a compulsory experiment. Okay, so it's activity to let you understand the phenomenon of total internal reflection and how we determine the critical angle. So you can see the aim of the experiment here will be you want to observe the phenomenon of the total internal reflection. Then the second one, we need to define the critical angle of the glass. Okay, so basically the apparatus will be set out as shown in this figure. So we have the semicircular glass block, we have the red box, and then white paper. Okay, so the first step, a light ray directed along the normal line. So the normal line will be here. So where you need to draw on your A4 paper. Okay, so through the semicircular glass block from the curved edge. So you can see the light ray from the red box is point towards the curved edge of the semicircular glass block, not the flat side of the semicircular glass block. Okay, and then you need to observe. Okay, so you can see this short video clip here. Okay, so you can see firstly, we need to draw the normal line where showing 0 degree at the A4 paper. Okay, so you can see there is no any refraction occur when the light ray passing through the normal line. Okay, then the next step, the light ray moves slowly from normal line to A. So A will be here. So that means from here moving to here to the point A. Okay, so to increase the angle incident. So initially is 0. Here is 0. So we need to increase the angle incident. Okay, so the changes in the refracted ray are observed. So as per mentioned just now, if let's say the angle incident is less than the critical angle, okay, so where you learn at 6.1 already, so the refraction will be occur. Okay, so you can look at the short video clip here. Okay, so you can see when we at the angle less than critical angle. So the line here is actually, this line is actually the critical angle. So, and we increase our angle incident to A, which is less than critical angle. So the refraction is occur. Okay, refraction. Okay, then when the angle of refraction where R equal to 90, so that means when our refracted angle here 90 degree. So that means we increase our incident angle to critical angle. So your refraction will be not occur anymore. And the angle, or we can say that the refraction is actually at the angle 90 lah. Okay. So okay, will be at here. So when we increase our critical angle, so you may see that the angle of refraction increases until reach the boundary line between glass block and the air here. So we know as a critical angle. So you need to measure. So what is the angle here? Which is C. So you will get your critical angle for this glass block. Okay, and then we continue increase the angle incident. So we will see total internal refraction will be occur as per definition we explained just now. Okay, you can see the angle incident I is increased further from the angle of measure at step 4. So that means we want to get the incident angle greater than the critical angle. Okay, so what will happen? You need to observe. Okay, so you can see. So this is a critical angle we want to measure. And then here you can see when our I greater than critical angle, so the total internal refraction will be occur. So you can see no more any refracted ray. Refracted ray can be seen at the A already because the light is refracted when our I greater than critical angle. Okay, so this is the end of this experiment where you can observe the total internal refraction as this short video here and the way how we determine the critical angle. Okay, so you may actually referring to my one of the video actually I did early of 2023. Okay, so you may go through this video to get more idea for this experiment. Okay, then the next, this is a summary of the result for activity 6.3. Okay, so basically you may classify the activity, the observational activity 6.3 to 4 cases here. So the first will be when I equal to 0, so where the ray light ray is actually at I equal to 0. So there will be no any refraction occur. So you can see light ray are not refracted. Okay, so this is a picture I took when I do the previous video. Okay, and then the next case will be where the eye less than the critical angle. Okay, so you can see light ray reflected away from normal. Okay, because the light ray here is from denser medium to lesser medium. So it will be occur normal refraction. Okay, normal refraction where the light ray will be away from the normal when travel from denser medium to lesser medium. And then the third cases here will be when I equal to critical angle, where you need to measure the angle of incident, where your refracted ray at the boundary between the semicircular glass block and the A, or we can mention that the angle of refraction is 90 degrees. Okay, so you can see here will be the refracted ray, and here will be have a weak refracted ray also actually, but become clearer. Okay, from I less than C to I equal to C. Okay, so it will be almost same as the picture I'm showing here. Okay, you can see here this is the incident ray, and here this is the refracted ray. Okay, and this angle of incident we know as critical angle. Okay, so when R equal to 90 degrees, I is known as critical angle. So in the experiment, I get about 40 degrees. Okay, so normally it will be about 42 degrees. Okay, then the next here will be the last case where the total internal reflection will be occur. Okay, so the incident angle now is greater than critical angle. So you can see the line, this line is actually critical angle. Okay, so when the incident ray greater than, the angle of incident ray is greater than critical angle, so you can see the obvious refracted ray can be observed. Okay, so this is the phenomenon where we know as total internal refraction. Okay, so this is a summary for the activity 6.3. Okay, then okay, so we finished already the discussion of standard 1, learning standard 1. So we go to our question number 1. So this is one of the questions from 2006. Okay, so let us go through the question together. So diagram 7.1 and 14.1 and 14.2 shows light ray traveling from glass to A. So the glass will be here, then A will be here. Okay, so which angle is the critical angle? Okay, so as per definition, we already learned just now. So the keyword here will be the incident angle at denser medium. So the incident ray will be here and here for diagram 14.1 and 14.2. So that means the angle will be here. Okay, then the second keyword here will be the refracted ray. The refracted angle is 90 degrees at less than median. Less than median will be here. Okay, so will be 90 degrees will be here. Right? So the answer is very clear that, so R will be critical angle. So answer is D. Okay, then we go to our next question, number 2. So this is also one of the SPM question 2019. Okay, so here will be the question. Okay, so diagram 20 shows the path of the light ray that pass through two medium of refractive index M1 and M2. So here we have two medium N1 and N2. Okay, so which pair produce the total internal reflection? Okay, so for total internal reflection to occur, as per mentioned just now, we have two conditions. So first, the light ray must be traveled from denser medium to less dense medium. Okay, so here you can see the incident ray is here. So light ray from denser medium. So definitely here N2 must be denser. Okay, so denser medium will have a greater refractive index. So here will be B and C lah. Okay, and then the second condition here will be angle of incident must be greater than critical angle. Okay, so critical angle represent as symbol C. So I must be greater than C. So answer will be B. Okay. Okay, so we go to the next learning standard. Okay, so learning standard 2. Okay, so here will be you need to relate the critical angle with the refractive index. So basically, you will be apply this formula, N equal to 1 over C. Okay, so here will be the discussion how you get the formula N equal to 1 over sine C. Okay, so the relationship between critical angle with symbol C and the refractive index with symbol N. Okay, so basically, the light ray, the incident ray will be from denser medium, which can be glass. Okay, so and then will be pass through less than medium. So here will be A. Okay, and then the critical angle will be the incident angle, which is C when your R refracted angle is 90 degrees. Okay, so the N where you learn in 6.1 will be sine I over sine R. Okay, so the I will be in A. However, you can see from this case, our I is actually in the glass. But you need to always remember, N is always greater than 1. So you must take your greater angle at the less than median, where will be always occur at A here. So the angle of I, where is actually out here, is 90 degrees. So sine 90 will be equal to 1. So you will get this formula lah. Okay, so here will be one of the example question in 2011. Okay, so where relate the N and C in this question. Okay, so diagram 19 show a ray of light propagate in a transparent semicircular block. So it will be like this. Okay, so what is the refracting index of the transparent block here? Okay, so firstly, you need to identify the angle of critical angle. So definitely here will be critical angle. So when refracted angle at less than median is 90, incident angle will be critical angle. Okay, so you just apply the formula you learned in previous slide, then substitute your C as 37 degrees. So you'll get your answer 1.66. So it's D. Okay, so we go to the next learning standard. Okay, so will be application of the critical angle total internal reflection in phenomenon, natural phenomenon, and also the application in our daily life. Okay, so firstly, the natural phenomenon total internal reflection. So here we discuss about the mirage. So what is a mirage? You can see from the figure. So the cloud image is formed at the root. Is one of the example we know as a mirage lah. Okay, so on a hot day, the layer of air near the ground are hotter. Okay, so we know already the specific heat capacity for the root is actually smaller, so it will be get hotter easily compared to A. Okay, so during the daytime, so the land of the root here will be hotter. So the air nearer to the root will be hot compared to the higher altitude. Okay, so the hot air will be expand, causes the density decreases. So you can see from the picture, so the hot air is less than, and then the cold air is denser. Okay, then the air at higher layer is colder and denser compared to the ground, compared to the air near the ground. I already mentioned just now. Okay, then the third will be the incident ray from the cloud pass through denser medium to less than medium, so be here. You can draw a normal line. So this will be the incident angle. This will be reflected angle. So when from denser medium to less than medium, so here incident should be I. Okay, I, then reflected angle here should be R. Will be like this. Here will be I. Here, so R will be greater than I. Okay, you can see here. The incident ray from the cloud pass through denser air layer to less dense air layer will reflected away from normal line. So the normal line I draw as a dashed line already. Okay, then the next total internal reflection occur when critical angle is larger. Okay, so you can see, so when the light pass through so many layers, so the angle of R will become greater and greater and greater. Okay, until the I will reach this point. So the incident angle is greater than critical angle of the A and causes the total internal reflection to occur. Okay, so the observer eyes will be the dashed line here. Will be see the image of the cloud. Okay, on the surface of the root as a pool of water. So this phenomenon we know as mirage. Okay, then the second phenomenon here is the formation of the rainbow. Okay, so first, rainbow is caused by the refraction, dispersion, and total internal reflection of the light within water droplet. Okay, so here, the circle here is actually the water droplet. Okay, so you may see the light pass through the water droplet initially will be reflected, refraction will be occur. So from here to here is actually refraction. Okay, then when reach here, the angle incident of the ray is greater than critical angle of the droplet. So this will cause total internal reflection to occur. So you can see the word is mentioned here. Total internal reflection occur at the back of the droplet. Okay, so the front will be reflection. Okay, so definitely will be slightly of the light also reflected. Okay, but here we focus to reflection for the front, and then back will be total internal reflection. Then when go to the another side here, you can see dispersion is occur. So the different line here showing different color component of rainbow, because the speed of the light for different color is different. Okay, so the white light from the sun and the rain droplet will reflected here. Dispersion, disperse. into its various color component. Okay, so the dispersed light will hit the back of doublet and undergo total internal refraction. So over here. Okay, so this is formation of rainbow. Okay, then we go to the application of total internal refraction. Okay, so the first will be prism periscope. So the periscope can using mirror to make the refraction occur. But here we're using the transparent glass block, which is known as a prism. Okay, so how the prism, the transparent prism can make the light to reflect. Okay, so here, the application here will be to view object behind obstacle. In submarine, periscope are used to observe ship on the surface of the sea. So this is the application of the periscope. Okay, so to construct a prism periscope, okay, so we need to have two right angle prism. So it'll be right angle. Okay, so here will be 45. Fitted at both end of the tube. So it'll be this and this. Okay, so light ray from the object will enter and pass through the first prism. So this will be the first prism. So you can see the light ray pass through first prism. Okay, without any refraction. Okay, so for transparent glass block, normally the refraction will be occur. But in this topic, you know already, when your incident angle is greater than critical angle, total internal refraction will be occur and not refraction. Okay, so this is what apply in this application. Okay, so the angle incident, which is 45 degree. Okay, so as per mentioned just now, the prism we choose will be 45 to ensure that the incident angle to reach the prism is 45. Okay, so which is greater than the critical angle of the prism. So the total internal refraction will be occur and will be reflected downward. Okay, so this will be the third point. Okay, so then the next. So when the light ray passes through the second prism, so it'll be here. So again, total internal reflection will be occur. So again, the incident ray reach the second prism will be also 45 degree, which is greater than the critical angle of the glass prism for this periscope. Okay, so you will see the image form is upright, same size as the object, and then vertical. So this will be the application of total internal reflection. Okay, then the third application here will be optical fiber. Okay, so an optical fiber consists of inner core with high refractive index and surrounded by layer of cladding of lower refractive index. Okay, so you can look at this figure. So inside the fiber optic here, okay, so the refractive index is higher, the material used compared to the cladding layer, so with the lower refractive index. Okay, so when the light ray move into inner core from one end, so be here. So total internal reflection occur continuously until it reach the other end. Okay, so as per mentioned just now, for total internal reflection occur, two conditions must be met. First must be the light ray must be from denser medium to less than medium. So the denser medium here referring to the inner core. Then the less than medium will be outer core. Or here is a layer of cladding. Okay, then the second, the incident angle to hit the inner core must be greater than critical angle. So the total internal reflection will be occur. Okay, so actually apply very simple condition where we discussed just now. Okay, so the advantage of using optical fiber will be here, much thinner and lighter, can carry more information. No interference from electromagnetic field and result in clearer connection. So no electrical resistance, and then no electric shock happen if the cable breaks. Okay, so this is a reference advantages for using the optical fiber cable here. So where you can actually apply in section B or C. Okay, then here the next will be the cat eyes refractor. Okay, so this is a cat eye refractor. So where commonly you can find at the surface of the root. Okay, so a cat eyes refractor is safety device in a marker of root user at night. So you can see this is a sample picture. Okay, you can get the cat eyes refractor on root. Okay, so the refractive spheres are set into the refractor, so be like this figure. Okay, so the light enter here will cause us total internal refraction to occur. So how to occur total internal refraction? Just now I mentioned already. So the light must be from denser to lesser medium. Then the incident angle at denser medium must be greater than critical angle. Okay, so here when the light ray from the headlight from car, okay, enter the refractor, so the prism inside the device will refract back as to the eyes of the root user. So will be reflected back to the driver. Okay. Okay, so we have complete our learning standard 3. So we can take 5. The Cikgu Hasnitah.
Okay. So students, we will be back after this short break, so don't go away.
Our hearts beat to the city streets. We began to feel the fire. We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine. Chase the night, wanna dance to the light. Pull stars from the sky, just two hearts running wild. Never sleep, never stop. As we shout from the top, we're gonna be two hearts running wild.
triangle. So the total interior angle for triangle is actually 180. So the angles B here will be 180 minus another two angle. So you will get 40. So B is 40. Then here is the right angle. Okay, so we'll be using 90 minus 40. So you get 50. So answer is C. Okay, so then the next will be question number 5. Okay, so here will be the question. So the diagram below shows a ray of light in glass slab. So what is the refracting index of the glass? So again, you need to identify. So where is your critical angle? Okay, so here will be the incident angle. And here will be the right angle, which is 90. Okay, so here will be the incident ray in the denser medium to less than median, first condition. Second, your refracted angle here at less than median is 90. So your incident angle will be critical angle. Okay, so here you can apply also the rule you learned at P3 USA. So here will be Z. So your C will be 55. So the refracting index relationship with the critical angle, we apply the formula you learned already, n equal to 1 over sine C. So you substitute your C as 55, you get answer is 1.22. Then the next question here will be objective question. A light ray is incidence on one side, so will be here, of a rectangular glass block. So the refracting angle here is 40, here given 40. Okay, and then the refracting index for the glass will be 1.49. Okay, so which option here showing the correct pathway of the light ray? Okay, so firstly, you need to get incident angle here. Whether the total internal reflection occur for case option B and D, or refraction occur for case option A and C. Okay, so to identify total internal reflection occur or not, so you need to identify the incident angle at the denser median. Okay, so that means you need to get the angle here. Okay, so how you get this angle? So here will be Z. Here is actually 40. So your incident angle here is 50. So what is the critical angle for the glass block? You can get by using refracting index and apply to the formula. Okay, so here will be the solution. Here will be the solution. Okay, so I saw one response from chat room. Okay, so welcome to my class.
Yeah,
Okay,
we have Dayang Kumarina there.
Yeah, welcome. Okay, so here, firstly, we need to identify the C for the glass block. So by using this formula, okay, so we get the C will be 42.16. Okay, so just now I already show you the incident angle for the all case in this option is actually the same, which is 50. So you can see the I is greater than critical angle. So the total internal reflection will be occur. So that means this will be wrong already. So we left B and D. Okay, so for B and D, so now we need to see both actually also occur, the reflection is occur. So the reflection occur from denser median to lesser median. So the right ray should be away from normal. So case B is away from normal. Case C, you can see the arrow close to the normal line. So the answer should be B lah. Okay, so you can see A and C is out. Okay, so the light travel from denser to less than medium. Okay, so the refraction is occur. And then here, we need to choose the light ray is away from normal due to the light travel from denser medium to less than medium. Okay, so answer very clear will be B. Here will be the sample question of 2011, section A, paper 2. Okay, so let us read the question together. So diagram 8.1 shows an incomplete light ray, will be this, entering the glass prism. So the refracting index of the glass prism is 1.5. Okay, so firstly, you need to calculate critical angle. So this question will be very easy. We just substitute to the formula we learned at Learning Center 2. Okay, which is I equal to 1 over sine C. Okay, so you need to rearrange, become arc sine 1 over n. So you substitute your n, which is given in the question, 1.5. So you'll get your critical angle is 41.81 degree. Okay, so please make sure your unit is given with 2 decimal places. Okay, so this will be A, 2 marks. First mark will be substitution. Second mark will be answer with correct unit and decimal places. Okay, then second, complete the light ray path from point O. Okay, so here we need to know the incident angle. So since this is 45 prism, so there will be 45 degree for incident angle. So you can see here will be greater than the critical angle. So a total internal reflection will be occur. Okay, so here incident angle is 45. I is greater than C. Total internal reflection will occur. So the answer will be line downward lah. Okay, then next will be based on answer 7A2. Okay, so then the light phenomenon involved. So definitely is total internal reflection. Okay, it's a very easy question actually, if you understand subtopic of 6.2. Okay, then here will be the question B. So diagram 8.2 shows the prism monocular. So with this, the position of 2 prisms on one side of the molecular are shown with this. Okay, so on diagram 8.3, draw the ray path entering the both prism. In your diagram, indicate the direction of the right path. Okay, so again, so this is a 45, I think. Okay, here. Okay, it will be incident angle will be greater than C that we expected, and total internal reflection will be occur. And for one prism, there will be 2 total internal reflection to occur. Okay, so you make sure give the direction for your answer. So basically, it will be this: the first light from outside entering the lens. Here will be the first total internal reflection. Then go here will be second, because the incident angle both will be 45. So it will be reflected to here. Then again, here will be occur also another 2 times of the total internal reflection. So this will be the arrow. Okay, so this is the answer for B. Okay, so here we go to our last question, 20 marks question. Example question from 2008 is a decision making question. So it will be section B for our KSSM format.
Yes. Sure.
Okay, so diagram 11.1 shows a light signal traveling through the optical fiber made of glass. Okay, so this is an application total internal reflection, just how we discussed already at Learning Center 3. Okay, so name the phenomenon occur at Y. So definitely will be total internal reflection, where we just learned at Learning Center 3. Okay, so name step 2 changes that happens to the light ray. Okay, so step 2 changes that happen to the light ray when it passes from A into optical fiber. Okay, so from A to optical fiber. So A will be less than medium. Then here will be denser medium. So the refraction is actually occur here. Okay, so the refraction, if you still remember the refraction of wave. Okay, so there will be 3 changes here. Okay, so firstly, you see just as I mentioned already. So the refraction is occur, and then from less dense medium to denser medium, which is air to inner core. Okay, so the speed will be changed, which is actually decreases. Direction will be changed. Okay, so here from less than medium to denser medium. So it will be moving towards normal. Okay, then the wavelength will be decreases, which will cause the speed decreases. Then the frequency is actually the same. But here the question asking you 2 changes. So you have 3 options for answer. Okay, so first will be the speed decreases when the light traveling from less than medium to denser medium. Then the direction changes where the light will be bent towards the normal, where I'm showing you just now already. Then the wavelength will be reduced. Okay, so 3 options here, maximum 2 marks. Okay, and then the last, the next question here, explain why the light ray follow the path shown in 11.1. Will be this. When hits the wall of the optical wire. So that means the question asking you why total internal reflection is occur. Okay, so just now I already mentioned for many times, there will be 2 conditions for total internal reflection to occur. Where the light ray traveling from inner core, which is denser, to the outer cladding, which is less dense. And the angle of incidence, which is showing as theta here, must be greater than critical angle. So if I say you mention these 2 conditions, you actually already get the maximum mark. Another answer advisable here will be applying of the law of refraction. Okay, so the sample answer here will be light traveling from denser glass into less dense outer cladding. Second, angle incidence is greater than critical angle. So this answer is already enough for you to get the maximum mark, where you learn through this subtopic 6.2. Another one will be the law of refraction. Okay, so you learn already at chapter 5. So where the incident angle is equal to refracted angle. So here will be the theta here will be equal to this theta. Okay, so this is the answer for B2. Okay, then next, here will be the decision making question, 10 marks question. Okay, so the optical fiber, okay, it's quite small. Huh? Okay, so the optical fiber in diagram 11.1 can be used in telecommunication and medicine. So you are asked to investigate the characteristic of optical fiber for use in this field shown in the table 11. So with this. So basically, the characteristic study here will be the fixture of optical fiber, comparison for the refractive index, inner core and outer core, flexibility and purity of the inner core. Okay, so explain the suitability for each fixture of the optical fiber 11, table 11 for communication, for use in telecommunication and medicine. Determine the most suitable optical fiber. Okay, so here you need to give your answer in table now. Okay, so firstly, for the fixture of fiber, optical fiber here, you got two options, single or bundle. Single will be only one big optical fiber. If I say bundle, they will be very, inside got very small fiber together. So which is the best option? So definitely is bundle lah, because
Yes.
the single optical fiber will be only allowed transferring for one signal. So for more fiber we use, we can transferring more
More
information.
signals, information.
Okay. Okay, so we'll choose Q, R, and T. Okay, then second, okay, so here will be the answer in table. First, we choose the bundle or find parallel optical fiber. You just copy your answer, your answer from question. Then reason, as per mentioned, able to carry thousands data signals simultaneously. Okay, so this is the reason. Then second, this already learned just now. So the light should be travel from denser medium to less dense medium. Okay, so the inner core will be denser. So the Ni here must be greater.
Greater.
So will be Ni must be greater. We have three options here. Okay, so you can see very obviously the option here should be R already. Okay, so you can focus your answer further at R already. Because all is out already. Here is out just now. Here is out for the first round. Then from second round, you're out already. Another two. Okay, so here we actually left one option. Okay, so you must already know your direction for answer. Okay, so the Ni greater than No because you want to let the total internal reflection to occur.
Okay.
Okay, so this is the answer. Produce total internal reflection. So here very clear that the flexibility will be high.
Should be high.
Okay, so can be used for a longer distance. So because the flexibility higher, so the fiber can be bent to different direction. Okay, then the next here, very clear that the purity of the inner core will be very high. So reason, advice here will be signal can travel over a long distance without losing information. Okay, so this is a purity. Okay, so we choose R, and then for the last option here, you need to copy all here. Abundant or fine parallel optic fiber will be the first comma. Okay, so here will be the refractive index of the inner core is greater than refractive index of outer cladding. Third, high flexibility. Then fourth, inner core with very high purity. So you will get total 10 marks here. Okay, then we go to our last two questions. Last 5 mark question here.
Yes.
Okay, so diagram 11.2 and 11.3 show a ray of light passing into glass and diamond respectively. Okay, so here will be the respective refractive index. Okay, so here asking you to calculate critical angle for respective material here. Okay, so for diamond and glass, okay, so the refractive index will be 1.5 and 2.42. Okay, so for glass, we're using formula sin C equal to 1 over N. Then we add sign, we can get the answer, 41.81. They will be same for the diamond also. So we get these two values. So make sure unit and 2 decimal places. So you'll get 2 marks. Okay, then the last will be, okay, copy the diagram 11.2 and 3. So that means your answer sheet, you need to copy these 2 diagrams. Okay, so complete the path of the light ray in the glass and in the diamond until it finally emerges from each object. So that means the light must be come out from the glass and diamond. Okay, so you can see here, you need to continue your path at here. So whether is reflection or total internal reflection. Okay, so to observe total internal reflection, we need to see incident angle at denser medium. So here the incident angle for glass is I. Then the critical angle for glass is 41.81. So that means for case 11.2, which is at glass, refraction will be occur because the incident angle is less than the critical angle. So you need to draw an arrow. Okay, so where the light is traveling from denser medium to less than medium. So the right ray will be refracted away from normal. Okay, so this is the tips I explained just now. So incident angle 30 degree, which is greater than critical angle for the glass. Refraction occur. So the light ray traveling from denser medium to less than medium. So your refracted angle must be greater than incident angle, where will be moving away from normal. So with this. So this will be first mark. Here will be 3 marks. Okay, so first mark will be for this figure. Okay, so make sure angle R is greater than your incident angle. Then for the second, here you can see the incident angle is 30. Then the diamond critical angle is about 24.41. So your incident angle is greater than critical angle. So the total internal reflection will be occur. Okay, so here will be the first. So you can see for diamond, okay, so I 30 degree, which is greater than its critical angle. So total internal reflection will be occur. So be here. Okay, sorry. Okay, so will be here. Here will be 30. Okay, then here will be 30 actually. Okay, so then you must draw your total internal reflection. You can draw 1 time, 2 times, 3 times also, no problem. Then end up, you can see from the question, the final ray will be emerges from the object. So it's actually reflection will be occur here. So first mark will be for your total internal reflection. Here is the first mark. Then your last mark will be reflection. Okay, so this will be 3 marks for this question. Okay, so that's all for my sharing for subtopic 6.2. So I pass back to Cikgu Hasnitah.
Okay, thank you very much, Mr. Peh, for your great sharing this evening. And thank you also to all the students and teachers who follow us since earlier until now. We are now at 4:36 p.m. So if you remember, students, for last year UAS, yeah, Mr. Peh, the topics is coming from these topics, right? Refraction of lights, UAS 2022, where the candidates need to draw the diagram when we introduce a light sources entering a semicircular block classes at 5 different angle. So student kena lukis gambar sinar cahaya yang terbias, and later they have to draw a graph of I against R. That was the question for last year UAS 2023, and this year
yeah.
it's about electric non-ohmic conductor. So if according to the pattern, the first year we have Form 5 experiment, and then Form 4, and then back to Form 5. So maybe for 2024, it will be on Form 4. But we never know for sure. That is only the pattern or analysis study. But overall, thank you very much for your time. And then student, I hope this session benefits not only for those Form 4 students, since most school have finished with the year-end examinations. So we may take this as a very good revision, especially for those SPM candidates who will be seated for physics paper on February 19. So you may take this opportunity as a very good revision for you. And don't forget to join us again next week. We have another 2 session on Friday, will be presented by Cikgu Rina Rashid. Will be on score A plus SPM on Friday 9:30 p.m. So she will be discussing a few examples of this year trial SPM, the hot topics on trial SPM for this year. So don't forget to be with us on that moment. Again, I repeat the day, Friday 9:30 a.m. And then on Sunday, we will continue with Form 4 classes with me. I will continue with 6.3. It is on thin lens formula Kantan nipis. So that will be on the LP. So we hope whatever classes we bring will bring benefit to all of you, especially to Form 4 and SPM for DLP and non-DLP students as well. So stay with us, and for those who are not subscribing to Mr.Peh channel, so let us give our strong support to him by click the subscribe button below, and you make it also all notifications, so you will be among the first who receive the notification whenever Mr.Peh is having a live classes or uploads a new videos. Not only for physics, because I see Mr.Peh also download a few videos on chemistry for Form 6 as well, right?
Yes.
Okay, so that will be good for the Form 6 students. So Mr.Peh, any last word for our students?
Okay, so as per mentioned by Cikgu Hasnitah, okay, so don't forget to follow our next physics classes, which is at Friday and together with Sunday. Okay, so our Panitia Physics is always together with you all. Okay, so that's all for me.
Okay, so until we meet again, student, thank you very much, and we wish you a very pleasant evening. Okay, bye bye, and see you again soon. Assalamualaikum dan selamat petang.